Good morning, everyone. My name is Thomas Metzger, and it's my great pleasure to welcome you on behalf of all the organizers to this small series of webinars prior to our next week's conference on the ultrafast antiferromagnetic writing on the 9th and 10th of May in Mainz. Together with our colleagues from Prague, Nijmegen, St. Petersburg, and Mainz, our goal was to bring together leading experts to identify next steps which would initiate a breakthrough in or towards the fastest and least dissipative writing of antiferromagnetic bits. Together with, or to stimulate the participation of early stage researchers in this workshop, we organized this mini webinar series, and our aim was to invite experts in closely related but already established fields. We had a lecture on the theory of antiferromagnetism, on ultrafast magnetism, and there will be one on antiferromagnetic spintronics. Today we will have the pleasure to meet the editor of Nature Nanotechnology. All these lectures are given prior to our next week's conference, as I mentioned, and they are hosted in the same fashion as prestigious SPICE-JGU-Mainz seminars. So around 1 hour of talk and some time reserved for questions. Those are organized in a webinar format, so all attendees are muted in the first place. And if you want to ask a question, I would like to ask you to just raise your hand during or after the seminar, or write in the Q&A. You can then be promoted to be a panelist and ask your question directly. All of these webinars will be live streamed on YouTube, and they are available also later on. Today's seminar will be given by Dr. Benjamin Heinrich, and tomorrow we will have an online lecture by Professor Thomas Jungwirth at 3 p.m. Being said, it's my great pleasure to welcome Dr. Benjamin Heinrich and thank him already for kindly accepting our invitation. He is the senior editor of Nature Nanotechnology, and I would just like to briefly introduce him. In 2006, Benjamin Heinrich graduated with diploma from the University of Leipzig in Germany. He moved on to do his PhD in France, in Strasbourg, and got it from there in 2010. Later on, he moved back to Berlin in Germany to become first an associate and then a senior editor for Nature Nanotechnology, which he is since 2020. His research interests are nano objects on metallic surfaces and many body phenomena involving magnetic impurities. He was awarded a prize for his thesis from the University of Strasbourg. And with that introduction, I will stop sharing my screen, and I would like to ask Dr. Heinrich to please share your screen and start whenever you like.
Did that work?
Yeah, perfect. Thank you.
Good morning, everyone. And yes, thank you very much for inviting me to give here a little introduction to Nature Nanotechnology and to receive your questions and then try to answer your questions and provide you some insights into the life of an editor. And as said, this talk is called Meet the Editor, and Meet the Editor without a lot of question and discussion isn't a meet, right? So I'll try to keep my presenting rather short, so I will not use 1.5 hours for that, but I will have you will have opportunities to ask questions in between, and just ask your questions. We can pause in between, and I'm happy to talk about what you're interested in. So let me get started, and just with a little bit of history. If you think of Nature as a journal, then you might be aware that this is rather old already, quite old journal, but by far it's not the oldest one you can think of. So there's other journals which have a much longer history, but still Nature has also on its own a history of more than 150 years now. And this started back in 1869. And as one of our ambitions and goals is to communicate the best and most important type of science to scientists around the world, but also not only to scientists, but also to the public, which is interested in science, and also to politicians, for example. So to be also a voice of science to the larger society. And so then, as you know, there's not only Nature, but in 1983, Nature, so Macmillan Publishing Group at those days, started to create a series of sub-journals to Nature. And this started with Nature Biotechnology, and then a couple of other life science related titles followed, with Nature Materials being the first physical science sister journal to Nature, which was published first in 2002. And then Nature Nanotech followed shortly after in 2006. And so we just celebrated our 15th anniversary last year. And if you want to see that in a bit more, on the bigger scale, and look at the whole Nature research portfolio, then you see there's not only Nature, which is the flagship journal, but there's the Nature research journals such as Nature Nanotechnology or Nature Physics, Nature Materials, Nature Chemistry, but also new titles like Nature Food or other titles dealing with environmental social science. These are rather specialized journals, but then there is another broader journal, which is Nature Communications, and with less selectivity, the communications journals such as Communications Physics or Communications Materials, and you might also know Scientific Reports. And if you think, why do we need this different types of journals, then you can think of the different importance and implications a certain research finding has to society. And Nature has a goal or the aim to publish the research with the widest importance and the strongest implications for society or for science. And the significance of a work published in Nature should be very obvious to any scientist actually in any type of research field in an ideal scenario. There might be papers which are a bit more specialized, but this is the ideal paper, ideal Nature paper that everyone who is doing science can understand and appreciate the importance of these findings. The Nature research journals are more specialized, but they have the aim to publish the most relevant advances in a certain field. And so the significance of this work should be apparent to at least everyone working in this discipline. So Nature Physics, every physicist should understand why this type of research is important. Even if they do not understand every detail of the findings, they should understand why this can be important for others in the field. Nature Communications is a bit less selective, but still wants to publish highly significant advances which influence the field, but the broad appeal is less important here, but it should still be very, very good science and high quality data and high quality science. The communications journals then are again more specialized, and they want to publish new findings and insights into focused areas of this particular research, while Scientific Reports then aims at works that are scientifically sound And this is more important than having very significance in that case. Now, you might have heard about the different publishing models. I'm just at the side mentioning that here. So while Nature Communications, the communications journals, and also scientific reports are all open access journals. So you can read them freely, but the authors or the institutions or their funders need to pay an open access fee to get this paper published. Nature and Nature research journals, for 1.5 years now, they are operated in so-called hybrid mode. So they have still the subscription model, but there's also the option to publish open access in Nature, but also Nature nanotechnology, for example. Now, when you think of these different types of journals in the family, what do we do differently with these papers? And you will understand that a paper in Nature will see a lot more copy editing, for example, being done. A lot of these papers are rewritten by our copy editors almost entirely and are reshaped. And there's a lot effort spent to make this science shine best, so that they are really accessible to a broad audience, not only to the expert, and also the editor's engagement in the review process, in the editing, in the scientific editing of the work. And so is much stronger at Nature than it is at communications journals. And for sure, the selectivity and for impact is strongest at Nature, while it is weakest in scientific reports. And this is also because Nature, but also Nature research journals, publish only a very selective number of articles. And so we have to be very selective when deciding to publish a paper. For example, Nature Nanotechnology publishes around 12, 13 papers per month. So you can imagine that covering all types of nanoscience and nanotechnology, this reduces the numbers we can publish on a certain subtopic dramatically. And this forces us to be very, very selective. Yeah. One word to publishing maybe I should add is that all our journals, they allow for the submission or the publication of your research, of the first version of the research on open access, on preprint servers such as arXiv. So we actually encourage our authors to do that, so they have their science out in the community, and then we can work on the paper to make it through the review process and make it best before it is then published after peer review process with us. So in my talk, I'd like to introduce you to Nature Nanotechnology slightly. Then I will talk about the editorial processes. So what happens to your manuscript after you've submitted it to us? So what are the processes which follow, and what happens between submission and final publication? I will talk also about editorial criteria. So what do we look for in a paper? Why do we publish certain papers and don't publish others? So what makes a paper of interest to us? And in the end, I will finish with just a brief personal overview about some latest research we published in Nature Nano, just to give you a slight idea about the about the breadth and the difference in topics we are covering at Nature now. But before I come to that, I'd like you to ask if you had any questions to me and would like to ask something about what I've talked already about till now, or anything else.
I just checked. I think so far we don't have any questions, but also in the previous two talks, we saw that most of them come in the end. So I would maybe just let you know if there are.
Okay, yeah, then we do that. Okay, but don't hesitate to ask questions also in between. I think that can be very helpful, because I might not go into details on some points, and which are maybe more of interest to you. So just let me know. Good. So talking about nature nanotechnology, I should maybe first introduce what you would consider probably most of what is nature nanotechnology, and that's the people working there and being in touch with the researchers and selecting the papers for publication, and that's the editors. So since January this year, we have a new chief editor. This is Alberto Moscatelli, who did a PhD in chemistry. Actually, he is very much interested in chemistry and but also photonics and plasmonics and optical nanoscience, I would say. And he has overtaken the journal like in January from our former chief editor Fabio Pulizzi, who was a physicist. And then we have 4 senior editors at the moment. This is Olga Mutnova. She has a PhD in electrical engineering, and she looks a lot into engineering type of papers, electronics, but also 2D materials, electronics, and related subjects, also neuromorphic computing and such topics. Yeah. Olga, for the moment, is based in London, but she will move to Japan in, probably end of this month if everything goes well. We have Wenji Sun, who's based in Shanghai, and she did her PhD in biochemistry, then worked for industries a little bit, and then came to publishing. And she is interested in nanotechnology related to energy. So this is a lot relates to batteries, so lithium-ion batteries and related science. Then she's also interested in catalysis and some type of biotechnology like nanopore sensing and so on. There's Chiara, who comes from nanobiotechnology, but now mainly handles papers on nanomedicine. So you, like all of us, are aware of the development of these of the mRNA vaccines against COVID in the last years. And this, for example, is a type of nanomedicine, a type of nanotechnology used in medicine, and she would cover these type of papers, but a lot others as well. Then there's me, having a PhD in condensed matter physics, even though I came from chemistry before, and I handle a lot of papers on related to condensed matter physics, nanoscience and condensed matter physics, but also scanning probe and some on quantum science, quantum nanoscience, I would call it. So single photon sources or spin qubits and so on. We have at the moment a vacancy in the team, so we will have a new editor beginning in July, who will work at the intersection between nanomedicine and biotechnology for us. And we are all longing for having this new editor with us, because at the moment we have a high workload distributing the work among the 5 of us. Good. So what are the I think the next slide I can almost skip, because you got this introduction already. So you've seen that I did a PhD in condensed matter physics using scanning probe techniques. Then I did a postdoc in Berlin working on superconductors and their interplay with magnetic entities on the superconductor, and so many body interactions, topological superconductivity, and so on. So Majorana fermions and related topics. And since 2018, yes, I joined Nature Nano, as you have heard before. Now, talking about Nature Nano and the scope, I'd maybe first like to re-emphasize that we are interested in nanotechnology, but it's the same footing we are interested in nanoscience. So fundamental science which relates which has a relation to Nano. And so here I just put together different types of topics which come across. You can read them yourself, but you see there's this very huge spread of different topics we are covering, as you have already seen with the editors we have, which come from very different disciplines. And this is just to give you a little flavor. And something which is a little bit special about us, I would say, or which we think is special about us, is that nano science and nanotechnology is in itself, in most cases, already interdisciplinary. And we really like this interdisciplinary. So we like research which spans or connects different areas of research. And this is something we really like to highlight within our pages. So in 2015, we had roughly this distribution of papers. So a lot about physics and nanomaterials and devices. That was 45% almost. So this would be topics Olga, me, or Alberto would cover. Then there's chemistry at the nanoscale, something Alberto would look into, sometimes maybe me. There's nanotechnology and society, something which our former chief editor was very interested in. And we have, as I said, a huge spread of papers in biotechnology and nanomedicine. This ratio since 2017, this proportion has grown. And so I think we are now moving more to 40% in this area. That's why we also need a new editor in this area. And sure, we also publish papers on technical developments, new instrumentation, which allow better insights into nano materials, nano physics, and so on. Good. So this is about the different topics we're covering, but how does a journal or how does an issue of Nature Nano look like? And different to the journals which are launched nowadays, also in the Nature portfolio, Nature Nano still has a printed issue, even though most our readers read us online or read downloaded PDFs, to be honest. But if you look into into one of our issues, you open the page, you will see there's different contributions to that. And we have, so the journal is divided into a part which is a so-called front half, where we publish secondary content. So this is in the first pages. And then in the back half, so the later pages, there we publish the primary research, so which is also our primary task, is these letter and articles where we publish new research findings, which are reported for the first time with us. Now, just what can be part of the front half? So there's editorials, for example, where we as editors write about topics which we believe are interesting to our readers, which are timely matters, either related to science itself or related to society, but important for science. For example, 2 years ago, we published this editorial on flying and the environmental impact of flying and traveling of researchers to conferences and so on, which is, in view of the climate crisis we're facing, a topic we should care about, and where we as scientists and science publishers should also think about alternatives or how we can best deal with this problematic. We also publish in the front half news and views articles, which are articles written by researchers on new findings. So new articles which come out, and these news and views articles are thought to be more accessible to a broader readership. So they're written in less formal style, less jargon, and should convey the main message of a paper in an easy form to make the best science we publish shine more to a broader audience, yeah, and make it accessible for a broader audience. And these pieces are usually commissioned by the editors to certain researchers. So we ask someone to write about something we are gonna publish soon, and make these pieces themselves. So, and we do not usually consider suggestions from youth and views submitted to us directly. On the other hand, we also publish theses. So this is more thought-provoking contributions of non-technical, so non-direct, matter which is not directly related to scientific findings, but it's more about science politics or fundings, or about the society and the interplay between research and society, or research and industry. These are also often commissioned. A piece which I also think is very important to our front half are the commentary pieces. And these are both commissions or may also be submitted to us. But if you submit a piece like that, it is better to first send an outline and discuss this with the editor if there's space for this type of opinion piece. And these are pieces of around 1,000 to 2,000 words, which deal with scientific controversies or policy matters directly related to science, and have a wide interest or to researchers, or are important topics for many researchers. And these are a possibility to bring a discussion which is there in science, make this publicly available and highlight certain aspects, or bring new ideas to how to deal with such problems, for example. Yeah. And for sure, we have also reviews and perspectives, and these are maybe different to reviews you read in some other outlets. We like to publish reviews which are rather conceptual than specialized, so which give a good, which give the overall picture, and with good schematics to give a good introduction to a certain field which is of relevance at the moment. So we like to have reviews which are conceptual, but they should be timely also. And most of our reviews are commissioned pieces. So we go to a conference, see a talk or a discussion, and then we go on and ask someone, a researcher, if they would not like to publish or write a review article for us on a certain topic. But they can also be, but we also welcome ideas. So if researchers have a good idea and think this is an important topic, there was huge development in the past and this should be covered and somehow brought together the different ideas, and then you can also come to us, send us an outline and discuss with the editor if this could be a piece for Nature Nano. Something we find is very important in reviews and also perspectives is that we want a forward-looking pieces. So we do not only want a description of the state of the art, citing all developments and every paper, every work which was published over the last 10 years, but what is important to us is that there is a clear idea where this is heading, this field is going, and giving also showing the bottlenecks which are there at the moment, and trying to analyze these bottlenecks and show solutions and how to go forward from here to overcome these. So that's it for the front half. So commissioned pieces, sometimes also pieces which are submitted to us, but this is all about non-primary research. Now let's come to the back half, and there we have articles and letters. This is two different forms we still have. So articles are a bit longer, more longer pieces, which are often about research which combines a lot of different techniques, a lot of different ideas brought together to make one, to bring out one single result, or sometimes also more than one result. But research which uses more, needs more space to convey the whole picture. And here, for example, this is an article from the battery. So no, this is actually a letter from the battery community we published a couple of years ago. And to be honest, even though we have many different types of front half research, we as editors, our main occupation is this the back half, so the primary research. That's where we spend most of our time on. Now, would there be questions on that part?
So far, I think we don't have any questions.
Okay, good. Then just, I'll go on and we'll see. We'll talk about questions later. So let's come now to what to some of you might look like a black box. This one is one which is built up into an airplane, but editorial processes and what's happening to your submission after, or to your work after submission, might look like a black box to you, because you submit your paper and then at a certain moment it will be published or it will not be published, but what happens in between? And I'd like you to understand what are the different steps and processes which are involved here and how you can react on them. And so this is an overview of the editorial workflow, and what we receive in Nature Nano, something like 180 to 230, sometimes 250 manuscripts per month. And these come into the submission system. There's a first quality check. And then we, as the editors of the journal, we meet 3 times a week for half an hour and distribute the different manuscripts depending on the topic of the manuscript to the different editors. So you've seen that we have very different backgrounds, and even though we widened our scope, so we handle much more, many more different topics than our original background was. But so we, with working at the journal, we learn and discover new fields every day, and so we can widen the scope. But still, I am not able to deal with a manuscript on nanomedicine, for example. So we distribute papers depending on the topic, and after this, the paper goes to my inbox, and then I try to come to a first decision within 4 to 10 days. So I aim for 5 days after the manuscript came into my inbox. So this is usually 2 days after submission. If it was submitted on a Friday, then it's maybe 3 days. But this first quality check takes a bit of time. So usually after 7 days after submission, we try to have a first decision. This is not always possible because sometimes we travel, sometimes we go to conferences, we are on holidays. So this might be delayed from time to time, but as a sum of rule, as a rule of thumb, we try to get back to the authors within 7 to 10 days. And so for this, I assess the manuscript, and then I decide whether we can send this out to external review, or we have to return this manuscript to the authors because I believe that it is not a good fit to our journal. And you see here, we reject like 85% directly at this stage and don't send out to review 85% of papers. And this is not because the work is not good or wrong. This is only because we believe that work does not match our editorial bar for this topic. So I know that this is very hard for an author to receive this, this email, but you should bear in mind that 85% of authors will face this decision. And so sleep about it before you take any action after that. Now, once the paper is returned to the author, usually the authors go somewhere else and publish paper somewhere else. There is also the option to appeal the decision if you really think that the decision is wrong and there was something, so the editor overlooked something in the paper which is of such importance that it justifies publication in this journal. If you appeal, take a calm approach, use arguments, and not arguments about your reputation or about how well this paper was received in the community, because this is anecdotal and I can't use it, but use scientific arguments and or provide more data or more experiments which underline the message and make it more of broader appeal, for example. Then there might be, if there's new additions to the paper, which makes the paper even stronger, a paper which had maybe, for example, being a bit preliminary in first submission, then there could be a good chance that the first decision will be different for the appeal. However, to be honest, at this stage, an appeal has rather a little chance to be successful. So I think appeals, something between maybe 10–15% of appeals are then sent out to review. But this takes time, right? This appeal process. And it usually takes longer than a usual first submission because we have to give priority to papers which we see first and not those which we have already once spent time on. And so this appeal process takes time, and often most of the cases, and really 80–90% of the cases, will end with the same decision. So we will return the paper to the authors without peer review. Now, if I decided that the paper is worth being considered for publication, because I think it's an important topic which is also backed up by data in the manuscript, and so then I will send out this to external review. I will look for reviewers, for experts in the field, and after then I contact reviewers. Ideally, these reviewers accept, otherwise I have to look for other reviewers. And then usually after 3 to 4, sometimes 5 weeks, the reviewers send in their report. We ask them for 2 weeks. This also happens, but usually it takes a bit longer than 2 weeks. All in all, from the decision to send it out to external review to a decision after review takes roughly 4 to 5 weeks, I would say, if it's good. Sometimes, unfortunately, it takes longer. So then if the reviews come back, I will go through all the reviews. I will assess the different arguments of the reviewers. I will check whether the arguments are about the science presented or they are only about the presentation. And depending on the different arguments from the reviewers, I will all take them together, try to also balance them in importance, and then take a decision. And either I will go for, I will understand that the work is either not based on solid science, or it is not of enough importance or enough impact that we can publish that in Nature Nano. Then we will return it to the author, so reject it. Otherwise, usually we will send a revised decision where the authors are given the possibility to improve their paper to make it suitable for Nature Nano. I think it almost never ever happens that in the first round, after the first round of review, we go to publication. This can maybe happen if a paper had been reviewed at Nature before and then just transmitted to us with a peer review process from Nature. Then maybe it was already improved and then we can decide directly for publication, but this is an exception. So usually it goes to revisions. The revisions come back to us, depending if we think the revisions are addressing the concerns of the reviewers. We've sent it back to the reviewers and then again wait for the reviews to come in, so the reports, and take a decision. This might go 2 or 3 circles, sometimes even 4. We try to limit the number of review rounds because this is, yeah, it's not good for, it takes a lot of time for the reviewers, for the authors. So we try to if we see a review process is going nowhere, then we will reject the paper instead of just going through another round of review. If we see that after a first revision, the main problems still remain and points of the reviewers have not been addressed, and there's the major issues are still remains, and we will return to the authors. Otherwise, when all the concerns of the reviewers are addressed, or with new data or new analysis or better presentation, then we will decide for publication. And this is in the end 7 to 8% of the papers which are submitted to us will end up being published. Yes, you see that when we return the paper to the authors here, you may also appeal this decision. But again, this is a time-consuming process, and you should only go down this path if you have really good grounds to think that you can convince the editor to send this back to the reviewers, and also the reviewers to see that what you have added in your revisions, so new experiments. If you do a new experiment which can better support your argument, then this might be a way to go. But again, it takes time, so maybe the better option is to publish elsewhere. Good. Now I've talked you through the process in general, but what do I do as an editor when I see a paper? When I see a paper first, so I need to filter out those papers which are of interest to the journal. And to do so, I study the paper in very much detail. Then I check the ideas of the paper and the findings of the paper against what is there in literature. So I need to know how much does this paper contribute to the evolution of the field? What is the step which advances, where this paper advances the knowledge in this field or the achievements in the field? And this is probably the crucial part to understand where is the advance of the paper compared to the literature. And sometimes if a paper is interdisciplinary, for example, I will discuss also this paper with my colleagues, with my Nature Nano colleagues, which are maybe more expert in this neighboring field where the paper crosses over to. Or if there is a very difficult decision and I'm not sure, then I will also discuss with a colleague and try to explain the situation. And usually then we come up with a decision together, or I come up with the decision after this reflection with my colleague. That helps also. So once I decided a paper is good or the idea of a paper is good to be published in Nature, then I will see that I will go and select reviewers. And to do so, I'll usually use 2 to 3, usually 3 reviewers. Sometimes it's only 2, sometimes it's 4. And what I need to make sure is that the expertise of the reviewers covers all the important parts of the paper. So if the paper is about theory and experiment, I need to have experts on both sides of the paper. And then I also try to balance a bit between younger PIs who are still very, very familiar with the technical aspects of a certain technique or so, with also more experienced PIs who have often, not always, right? This is difficult to speak in general, but often more experienced researchers have a wide, broad view of science in general, and so they can maybe have a better feeling on how important this finding could also be for other fields or neighboring fields, and how it relates to findings in other fields. Now, after doing so and securing the reviewers, I'll follow the scientific arguments of the reviewers, of the rebuttal, and then make a decision and try to do that in the best interest of science and of our readers. What's important to know is that we do not count votes. So if there's 2 reviewers in favor of publication and 1 is against it, that doesn't mean that we will publish the paper. Also, the other way around might be true, even though this is this is rare, I would say, but that can also happen. So we're not counting votes, but we are looking at the arguments. And it could be that only one is expert on a certain technique, and this reviewer actually tells me, well, yes, everything else is fine, but the arguments or what the authors deduced from this experiment is just not solidly argued and is probably wrong. Then I will not publish this, even though the other reviewers were satisfied with the answer of the authors, if I know this reviewer is the expert on that technique, for example. Or there might be other cases. And for sure, we try to be available to authors and reviewers. We try to communicate our decisions and explain them if we didn't do so in the first time. So you can contact us if you want to. What we then do after deciding for publishing a paper, we will usually, as editors, look at the abstract and see if this abstract is accessible to a broad readership and not only to the experts. And then often people end up rewriting abstracts or at least reshaping it, taking certain parts and putting it differently together to make it more suitable for a broad readership, not only for experts. And yes, sometimes we also tweak the introduction and conclusions. We will also, if needed, look at the structure of the paper and give recommendations how to restructure the paper or include paper material from this SI into the main paper, or the other way around. We move some material from the main paper to the SI to make the story more stringent and more accessible. Yeah, and one thing we also try to do, even though that's with little time, this is difficult task. We try to remove hype, which is not justified by the science presented. So we do not want to overhype the findings of our papers, but I'm very much in favor of being clear about what is achieved in a paper, what can follow out of that, but not in a general meaning. But if you have implications, then you need to describe them and have a straightforward way to go there. Otherwise, just rather don't mention them and be clear what's the result of the paper. That is, usually the results of the papers are already important enough. They don't need emphasized through hypes or unjustified hypes, let's say. And yes, once we decided and we published the paper, we also might commission news and views papers on news and views articles on certain papers which we think are of particular interest to a broad readership, and then these commissions, or which are very difficult to understand because they're very technical, and this technicality is needed for the paper to be understood and to be correct. Then still we might want to have a news and views accompanying this piece to make it with less jargon, make the main idea shine to a broad readership. We have also, as we are print issue, print journal, we have also a cover, and each issue has a cover which comes from one of the papers. So if your paper is selected for publication with us, you can also suggest a certain cover image. However, there are various limitations to what we can accept for cover images and what not. So, and then there's 12 pieces in the journal, in the issue. So don't be sad if it's not your cover which we are taking. We will also tweet about papers, and sometimes we publish press releases about findings which are important for broad, more of societal concern, for example. Now, what do I look for when I have a manuscript on my desk? The very simple answer is great science. But I know that's also a superficial answer and somehow a stupid answer, because yes, we are all looking for great science, but what's great science? So if I want to go a bit more into detail, what's important to us is that research is original. So it is different from what I've seen yesterday and before yesterday and the day before. Important is a substantial advance for the field. So it's not a small tweak to something, but it needs to be substantial, not just moving a little atom here or there and understanding this slight detail a bit better. No, we want a substantial advance. Or you have conceptual novelty. So if you introduce a new technique or a new device type, where you take a new concept, build a device, and this device has actually important implications, either for research or for technology. So you use a new material in a solar cell, and this gives you very striking performance improvements of the solar cell, for example. Or you change the design of the solar cell, and by this you can increase the energy efficiency of your solar cell by 5%, which in solar cell research is a huge number, right? So what can also be is an unexpected discovery. So that's difficult to give an example, but for example, I published a paper, or researchers published with us a paper I handled on a gating effect in a metallic superconductor a couple of years ago. This effect is rather unexpected, that you can gate a metal, which is usually due to the high electron or charge carrier density in a metal. Gating will always be screened, and so there's no effect on the metal. But in this case, there's good evidence that there is some type of gating effect, even though this research is highly controversial, and I think it is still not settled at the moment. What is the fundamental reason for this? But it is an unexpected discovery, very well documented with experiments, and so in this case, it was worth publishing that and seeing where this controversy will go. Your paper could also overcome a technological bottleneck or a certain threshold needed for a certain application. For example, in quantum communication, quantum technologies or quantum computing, you want to have qubits which have an error rate which is below the threshold for error correction. And so with certain codes. And here presenting a qubit similar to earlier ones, but one which has now reduced the error rate to a rate which is compatible with error correction, then this could be overcoming this bottleneck and open up a field to a future, or to scaling, for example. Then for sure we are looking for broad interest and practical applicability. That is more, my papers usually don't have that too much, but there's my colleagues look at papers like this. Or your paper changes the understanding of a certain topic, that could also be. And for sure, all our papers should have high quality data and should be technically sound. There's no way around that. If a paper is not sound, we should not publish that. For sure, that might happen, but usually the review process should reveal these non-sound papers. So if you want to summarize this, we are looking for a significant scientific or technological advance that colleagues outside of this actual field can appreciate. So, for example, in IFM spintronics, the results should also be such that someone not working in spintronics can understand why this is important for spintronics. And sure, we would like to have impact. So maybe just to give you a flavor on novelty, or give you an argument, because you can say every paper which is published should be novel as such, but then there's different degrees of importance of this novelty. And yeah, if you can look at this little sketch here, and I think you understand where there is a difference between the two, right? And you will also follow me when I say, yes, this one might be more important than this one here. Now, if you look at papers which publish, then they come with advances in usually in three different topics. Either they are mechanistic advances, so they increase the understanding. They might have practical advance, so you do something, a small or larger tweak to a technology, and then there's remarkable practical implications. So the yield of a certain production process in chemistry increases by a lot, and so saves resources, and is very important for technology or for industry. And then lastly, there can be the conceptual advance. So you do something in a new way, in a way nobody has done it before, and by this you achieve a new property. You can understand new science, or get a new type of device which has properties which are not achievable with other concepts. Usually a paper is easy to judge if it's very far in one of these corners. So if you have a practical advance and that's a topic of the paper, then I can quite easily understand if this is a good fit for us or not, or if it's far in this mechanistic advance or in the conceptual. But often papers are somewhere in between, and they have a bit of practical advance, a bit of conceptual advance, or some mechanistic advance and conceptual advance. And these are more difficult to judge because you have to see all arguments and see if in total this actually brings our understanding of a field forward or not. And last but not least, there's also beauty in science. And when I see a paper which is with beautiful science, and that really makes my day. So I also understand that this is something which is very personal and subjective, and in an ideal world, every researcher does beautiful research, even though not every of this beautiful research is of important or of very high importance, but then still it's beautiful, and that's a value in its own. So only beauty will not make it to us. And beauty, I don't mean beautiful figures or so, right? I mean beautiful science. Okay, just to give you an idea of papers where I can briefly tell you why I think this is an important work and which was published with that. So you might be aware of a field where people try to use molecules, complex molecules, to build machines out of that, or motors. And in this paper here, the Benjamin group, they decided to use these a type of molecular motor molecule and combine this with the concept of metal organic framework. So metal organic frameworks are self-assembled 3D structures built out of some organic compound and some metal, so coordination networks, but in 3D, and they can, for example, be used to store some gas or so. And here, if you combine this idea, you have a 3D array of molecular motors. And now, if the idea is that you can use these motors, for example, to propel material through this single crystal, so through this MOF, this metal organic network. And I think here's the idea to combine these two fields, the metal organic networks, or metal organic frameworks, with this molecular motor, and bring them together is a beautiful idea, and might open up new science where you can use these MOFs now combined with some chemical action. So I think this is a good example. Another one paper I handled was a paper where researchers from IBM in Korea, they use a scanning probe machine, a scanning SDM actually, and transfer the concept of nuclear magnetic resonance to the level of a single atom. So they use NMR pulses on an STM and can detect the NMR signal of a single magnetic atom on the surface. So usually NMR is an ensemble measurement, right? You probe millions of atoms and their spins. And here they bring this down to a single atom level and can manipulate the polarization of the spins in these atoms, and also by this technique probe interactions of a spin interaction between different atoms, for example. And so I think this concept of bringing this macroscopic techniques, this ensemble measurement to a single atom level is a beautiful example of research. And now you might wonder why some papers are not published with us. And this is often because they're not novel enough or not unexpected, but you see the experiment and you think, okay, the result is good, but everyone would have expected this result, this outcome. So why should a broad readership bother to read this? Or the advance is too incremental. So it is the next obvious step and it advances the field, but only slightly. It could also be that the work is too preliminary. That is difficult cases. So there is a measurement, has a surprising result, an interesting result in itself, but it is not backed up with enough other experiments or cross-check experiments. There's no other explanations are not excluded by different experimental approaches or so. So only the observation sometimes might not be enough, because it could be a trivial fact and you need to exclude this triviality, for example. Sometimes a technological advance comes, but it doesn't demonstrate practical implications or relevance for real world applications, because yes, it improves the yield of this technique, but then there's 5 other techniques which do the same thing in a similar good way. So I'm not in the 5th technique, I'm maybe not so interested in it. Confirmatory science is important for fields so reproducibility is important, but cannot usually be published with us. If papers are technically not sound, and I see that, or the reviewers see that, then this will not be published. And salami slicing is something which goes together with too incremental. So if you have a great result, but you slice it up in 10 different papers, then every paper reports only a very small advance. Altogether, it would be a great advance, but only this single slice is maybe then not important enough for us. Now I will give you a little overview how much time I spent with manuscript for the first decision, right? When this manuscript comes to my desk, and if it's a very bad manuscript, it goes between 30 minutes and 120 minutes. But very bad manuscripts are the exception, right? Most of our papers are good science papers. And then it takes hours. It takes 2 hours, it may take 3 hours sometimes. It takes days to come to a decision. I will not work like 5 days on a single paper, but might take a bit more time to understand where this is going. I might need to discuss with a colleague. So good papers are difficult. And then sometimes there's these outstanding papers where I open the paper, I read the introduction, I look at the figures, and I see this could be great. And this is really outstanding science. Then I still need to do a background check on the literature, see if the authors have not like forgotten to cite certain other findings, recent findings or so. But these papers, outstanding papers, go quicker. However, they are very rare also. So then for these papers, I might to decide to find referees. And for outstanding papers, usually you realize that it's easier to find referees because referees are more likely to accept the paper which sounds interesting than to review a paper which is just good. And the most likely outcome is, that for an outstanding paper, there will be a revised decision to improve the paper further and make it waterproof. Good manuscripts might be rejected with or without review. Some of them are auto-published, which is totally fine, but there everything can happen, and hopefully bad papers will never make it to the reviewer. My job is to make sure that I'm not missing out on the outstanding papers, so that I find every outstanding paper. And for that, to do so, I also need to send out good papers, some of the good papers where I'm just not sure if it's outstanding or not. Sometimes I just don't know. And then I still do that. I send it out. And your job, if you mind, is make this decision easy. If you mind, it's not only for my sake, but it's also for the sake of your readers in the end, and for the sake of the reviews, because it's a well-presented paper which gives all the necessary details about them. So all the necessary details about the background and the state of the art, but not unnecessary ones. So not outrageous on the background, on the introduction, but the important findings need to be mentioned so that I know from where to go to see how this advance relates to literature, right? That's important. Then a clear story, good prepared, well-readable figures, a good structure in the paper. That's what's your job, and not only for me, but for your reader in general. Now just a little mentioning on the editorial criteria and the editorial bar. So this might oscillate a bit depending on the field, but as you've seen, we publish 7 to 10% of the papers, but it depends a bit on the subject, and if there's new exciting areas or well-established papers, this might also oscillate a bit. So in new fields, there's often important finding everything which we learn in a new field in the beginning, or most of it, is of importance. But then if after 20 years of research, there's only few papers which really bring the field still forward. Do we look for citations? We look for potential impact. And this may sometimes translate to citations, but sometimes not. And I try not to think about citations. I try to think about, is this important research? And then citations will follow. And sure, we sometimes get it wrong, right? Everyone does mistakes, so we are humans and we do mistakes. So if you really think there's a mistake, contact the editor. But maybe sleep it over and rethink if there is a mistake or it's just a different perception of your research, right? So I probably skip that again, and we just now in the very end, before I finish, I give you a slight flavor of what type of research is published in Nature Nano. Just I mentioned that in the beginning, but maybe with some slides will give you a better understanding how broad the scope of this journal is. So, for example, recently we published a paper on probing the motion of single bacteria with a graphene drum, so a graphene membrane, and then this was translated to an electrical signal, which can also give sound. And this could be important for antibiotics research, for example, because you see when you add antibiotics to this solution where the bacteria are in, you see that the motion of the bacteria, how fast the motion of the bacteria changes or stops actually. So how long does this process, for example, take to kill the bacteria with the antibacterial. Okay, then a topic I'm also very much interested is the 3D magnetism and the visualization of 3D magnetism. And for example, here the authors showed how they could create very complex 3D magnetic textures by creating a helix of, so 3D magnetic textures in free space by having a helix of magnetic material in 3D. We are looking also on 2D materials a lot and applications of 2D materials. Here, for example, we published last year 2 papers on Josephson junctions made from twisted bilayer, magic angle twisted bilayer graphene, and devices made out of these. We look at single molecular reactions, and for example, here with a single molecular junction made from some graphene electrodes on a device chip, researchers were able to look at on every single step of a catalytic reaction, which was also fascinating for chemistry, I would say. We look into topological physics and topological materials, artificial materials like this nanomechanical resonator array, or also to condensed matter real type materials. We look into neuromorphic computing, into single photon sources, how you, for example, this paper used stimulated emission, something we know from laser physics, but here applied to single photon sources, and this enabled to reduce the time jitter of the emission of the single photon, for example. We look into spintronics and now into quantum in nanoscience. There was, for example, this review we published last year by many different authors from different fields of nanoscience, which introduced the concept of quantum coherent nanoscience. So different topics in nanoscience, which all make use of the concept of quantum coherence, a trend which is there for now 10, 15 years maybe in our fields. And yes, we look also into spintronics, more classical on a wafer scale level, where dynamics of spin transfer torque and spin orbit torque switching in a wafer scale type MTG was explored, or also antiferromagnetic spintronics, like in this review here we published in 2016. Before I finish, just a short word on what I personally think is a good paper, and that is general. It doesn't depend if this is a good paper for Nature Nano or not, but this is something I would like you to bear in mind when you start writing or when you write your paper. That is, a good paper has a purpose. So why are you doing this research? So what is the question you want to solve? Then there should be good understanding in a good paper. So control, you need to be in control of the experiment and of the outcome. So, and ideally, there is something special about your paper. There is scientific intuition. So you did an experiment nobody thought about because you had this idea this could work out. Or you use an established theory to explain something in a different field, and you show that this actually works out very nicely. And yes, you should have always a bottom line. So the reader should know at the end of the paper why this is important, or what they can learn from this paper. And this all, what I've presented to you is comes with the caveat that we as editors, we cannot do anything without our authors. So the good quality papers we publish come from our authors, and so the quality stems from them, and we can only try to promote these. And we depend on the sort of work of our referees who detect and improve suitable papers. And yeah, without the support of the community and the work of the community, we could not exist. I'd like to thank you for your attention, and yeah, happy to take any questions you have.
First of all, I would like to thank you very much for insightful talk with, I think, or at least to my understanding, a lot of unknown insights in the work of nature nanotechnologies, and also your work as a senior editor. I also have to point out that already a lot of my questions, 4 to 5, were answered during the talk. So unfortunately, I couldn't provide you with some there. For example, what I was very curious about are exactly those details of the first review process or the selection of external reviewers. And I think you gave a perfect description of this. I still have some. I see that someone else is having a question. So I would like to just promote Sumit Ghosh, and you can go ahead and please ask your question.
Hello. Hello. Thanks for this wonderful talk. For me also, most of the question has been answered, but I would still like to ask you, so as an editor, when you receive the paper, where would you focus most, on the overall message or the technicalities?
It's both, unfortunately. So it is the overall message is what decides whether this could be suitable for me, for our journal or not. Okay. Right? But I need to see that there is, at least from my non-specialist viewpoint, enough data to support this.
Okay.
Or there is at least, there's enough data to support. Now, I'm not an expert in every field I handle, so not an expert like a researcher is. So that's why we have the reviewers, which then need to check for actually the technical aspect. However, if I see there is a nice idea in a paper, but there's no data to back that up, I will, if I understand that, then I will not send out the paper, because then it is too preliminary, right? There is the idea, but if the idea is not proven, then what can my reviewers say? They will say the same, right? If there's no data. And however, sometimes there's cases where I understand the idea and it's good, and then there is some data, and I do not understand that these data are actually not proving the point. That can happen, right? But then hopefully my reviewers understand that.
I see. Okay, thank you.
I saw there's another question. Maybe I can also rephrase it a bit. The question is, how did you become senior editor of Nature Nanotechnology? And maybe, moreover, you can elaborate a bit on what does it take to become an editor, and what the steps brought you there during your career as a researcher.
So yeah, as you've seen, I did a PhD in surface science or condensed matter physics. And then I did a postdoc in Berlin, and after some years in research, I decided that my position in research, or that I had enough of doing research myself. So I felt that I would not contribute in a super meaningful way to research myself, or I could contribute better by doing something else. And so I was looking for some alternative career paths, and I just applied for the opening of the senior editor position at Nature Nano back in 2017. That was in fall, and then I went through a selection process and just got the job. Before I did not do anything particular to prepare myself to become an editor. However, by doing research in a bit different fields, this already prepared me quite good. So I have some fundamental understanding of how research works, and also of condensed matter physics. I have some understanding, and then I needed, when I started the job, I needed to explore new fields and widen my scope. But the basics I had from my PhD and postdoc, for example. There are some of my colleagues which have, or not in Nature Nano, but in other journals, there are some colleagues who have only done a PhD and then directly started as an editor. That can work out, that's fine. However, I think a postdoc experience is a non-negligible advantage, because this usually helps you to get a bigger picture and to gain some insights beyond your core expertise of research already, and then it's easier to expand even more when you become an editor. So if you are interested in that, just look out on, I think for Springer Nature, I know that for the Nature journals, there is openings in many, in different fields, like all the time. So okay, then the specifics might be different. But for example, at the moment, there's an opening at Nature Physics in condensed matter physics. So they look for physicists from condensed matter physics as an editor. So usually you would start as an associate editor, and those openings there are with other publishers as well, right? Not only with us, but though one has to say that there's many publishers who work not with full-time editors, but with researchers doing the editor job. My job, or they have only a very limited number of full-time editors, and then an external editorial board made from researchers, like all the like JGU, for example, or Nano letters. But we work as full-time editors, so this might be a bit different, right?
All right, thanks a lot for the extended answer. I think this is exactly what we were looking for. If I may, and I don't see any further questions, I would like to ask one myself, just out of curiosity. You mentioned that you encourage researchers to put their work just as a preprint on arXiv before they bring it to Nature Nanotechnology or other journals. My question would be, did you recognize a significant, to say, change in the quality of manuscripts since that is present?
No, I cannot. Actually, I cannot comment on that, because I joined the journal long after this was already implemented. So I think for Nature Nano, we long were okay with researchers having their papers out on the archive. That's in physics, that's the preprint journal, preprint server, right? So having the paper out on the archive and then submitting to us, or at the same time submitting to us and then putting it on the archive. So I cannot say if this changed the quality, but for me it is not so much about the quality, but I think for physics at least, this preprint server changed a bit the way science is communicated, and I think in a good way, because results are already discussed early on, even because this review process might take a year from submission to final publication, and so I think that's a good way, and that's why we encourage that, not so much to improve the quality. So I think that if that comes, that's good, but I think that's a minor issue. To me, it's more about communicating science, and there we really encourage that. Maybe something I should add is manuscript versions which are after the review process, so where the input from the reviewers comes and from the editor, these should not be put on the archive, at least not within the first 6 months after publication. Afterwards, you can do what you like, but officially, so the guideline is you may the manuscript you first submit, you can put that on the archive whenever you like. Later on, after publication, there is an embargo period of 6 months.
All right, thanks for answering question, and thanks again for a very great talk. I don't see any further questions, so I would close the seminar for today. Thank you again. Thank all the people who attended, and yeah, I hope to see you then next week in our workshop close to Mainz.
Yeah, hope to see you there.
Yeah.
Thank you.